Hello everyone. Today I want to share some research / experiments that I've done with image synthesis using neural networks. What's interesting about this research is that it generates images without a discriminator. That means that it's not any kind of adversarial network whatsoever. It's not a GAN. I achieved this through a modified form of perceptual loss where instead of matching the mean squared error or the mean absolute error of neural activations in some kind of third pre-trained network, I instead matched the statistical properties using a Pearson distance. So here are some examples before we get too far in. What you see right here are some input, output, and ideal examples. So on the left right here, you see the input, and so in this case, the input is the outside lines as resulted of a Sorbill filter, along with a very low resolution color map. In this case, the color map is a 16 by 16 scaled down version of the image that's been then scaled right back up to be 512 by 512. So it's, very low resolution as you can tell. And then in the middle here, you can see the neural net's actual output after training. And you can see, pretty good detail. And then on the far right, you can see the actual target, right? So just some examples to kind of like motivate this video, right? So the network uses a U-net. But it has a few twists, right? So the first twist is that instead of a normal convolutional kind of like normalization ReLU style, instead it uses what I'm calling the basis network, is that it utilizes weights that were derived off other pre-trained neural networks, but the way that the weights are derived is by running SVD on a pre-trained neural network's weights to get what amounts to the neural net's the basis functions. And so that's what you see right here that's highlighted. But this will ultimately be trained further, to be customized for each layer. But I found that this enables the neural net to have a good starting spot and to more quickly train, and to enable you to have a lot fewer parameters that require training. So what you'll see right on this line right here is, the parameters that will actually be trained for this network. And so instead of being input output 3 by 3, which amounts to 9 filters per cell, instead it's just 3 filters per cell, because each of these 3 filters becomes a value that's utilized as a coefficient for this, this right here, and it's shared rather across the whole layer. So you need only 3 per cell instead of 9 per cell, and so that's great, right? And so you can see right here some code as to like how we take the basis weights and we calculate them to get the actual weights for the layer, and then we apply the calculated weights to be used as the actual weights for the convolution right here. And then instead of doing ReLU and the batch NOR, instead I use an SELU, which is just a different kind of activation function. I've found that for these things it works the best. So that's the basic part on that. And so let's see, yeah. So we saw some pictures of input output of the neural net, and it's cool because you're able to get like pretty good quality without using an adversarial approach. So that's interesting if people have challenges when they train their own networks, and maybe they are having trouble training like a normal GAN, which I've heard many cases is the case. So just more examples, input output target, right? So I want to show you guys a second experiment that I have performed using the same technique, but instead of doing so what's changed in this one is instead of the input being, as you see right here, where it's very low resolution color map coupled with these lines, right? Instead, what it does is, I'll show you a picture. One momento, por favor. Here is another example of the same technique used for this that is instead applied to faces. And this is also, a pretty high resolution input in the sense that the output should be 512 pixels per image instead of like 256 or whatever else. And all this was trained with a single GPU for less than 48 hours. In fact, you can get very good results with even as low as 24 hours of training for a very large set. And so what you can see right here is that the input in this case for the neural net is landmark aspects of the face rendered into these red lines. And you can see for the eyebrows, for the eyes, the nose, the mouth, etc. Right? And then this is the input coupled with what's on this green channel. And what this green channel is it's a unique random code for each person that I've ID'd within my source video. And so what's really interesting about that is then you can modify the green input channel and change how the person looks, like who are they, right? While keeping the same facial pose, as it were, right? So this is cool. But then if you scramble around the codes, the green pose codes, you can see something like this. And so same thing, same input output, but now I've scrambled the codes around, and so they don't look like the same people, even though they have the same, facial expression, you would say, right? And so this is, same person, same code, right? This is same facial expression, but a modified code, right? So you can see like they're looking in the same direction, but they're not the same person as they are here. So all this is utilized with the same UNet architecture. Let's see, what else is there to say? Oh yeah, so the training is interesting because one other thing that I've seen that helps a lot is to apply what it's called a mean teacher. It's kind of a funny, thing that they called it. But pretty much what it is to just take a running average of a neural net's weights over, n iterations. And in this case, I'm doing 5, and it's an exponentially decaying average. So that means that the most recent instance of the neural net as it trains has the most weight, and then it exponentially drops down in terms of weight for each subsequent train cycle. And so I just keep the last 5 and use that, and I found that also helps the neural net to converge to a more distinct set of outputs. So these tricks all combined kind of make for some nice output without having to have like a massive amount of infrastructure the way some other approaches require, like NVIDIA's or whatever else. So anyways, thought you guys would be interested to hear. Bye bye.